Hello. I'm sorry I can't be there with you, but I'll be as soon as I can. All right, so today we're going to start with a new lesson. If you can see, we're not doing test of the past lesson because I'm not going to be there to give a full review. So since it's almost the end of the term, I don't want to make your grades go lower because you're not prepared for the test. So we're going to skip that evaluation. I'm going to evaluate that lesson with all the practices that you've done. If you have any practices that you haven't done, okay, please go ahead and do it because it's very important for you to get your grades a little better, okay? I'm going to be receiving late works until Thursday, let's say by 5 p.m. So I will have the time to correct them and grade them, okay? So that will be like what you need to do to improve your grades a little bit. Good. So today we're going to start the new lesson. It's lesson 6.1, page number 319. It's lesson 6.1. It's called Solve System of Equations by Graphing. Go ahead and get your books. If you don't have them, you can pause the video right now and go get your books. So when you're ready, you can push play. Good. So I hope you're all ready. If you don't have your books or you cannot find it, go ahead and get together with a classmate so you can work in your notebooks. If you don't have your math notebook, you can go ahead and work in any other notebook, but I need you to be working, okay? So it says, I can write equations in a slope-intercept form in order to graph them and use the graphs to solve a system of equations. So let's learn first what a system of equations is. And right here we learn two or more equations with the same set of variables are called a system of equations. For example, y is equal to 5x and y is equal to 2x plus 30. Together are a system of equations. So there are two or more equations that have the same set of variables. If you see the first one, y is equal to 5x, well, it has a y and it has an x, right? And the other one, y is equal to 2x plus 30, it's also a system of equation. It's also an equation of this system of equation because it has y and x, okay? The solution of this system of equations is 10, 50. If you see, you may notice that this right here is something that you have seen in the past lessons. And that's a coordinate, okay? These are points in a graph. This is exactly 1 point, right? It gives you the coordinates for 1 point in a graph. So all the solutions for the systems of equations are going to be coordinates in a graph. Good. What do we need to do to solve them or to know that this is true? So we're going to write the equations. Okay, right here, they are written already in your books. Y is equal to 5x and y is equal to 2x plus 30. Let's see why this is a solution. So instead of this, we're going to put, instead of the variables, y and x, we're going to put the points that we have right there in the solution. So instead of y, we're going to put 50. And instead of x, we're going to put 10. So right here, when we simplify it, 50, it's equal to 5 times 10, 50. So that's correct, right? 50 is equal to 50. Now let's do it with the other one. The other one needs also to work, right? Instead of y, we're going to put 50. And instead of x, we're going to put 10. So 50, it's equal to 2 times 10, it's 20, plus 30 is 50. So 50 is equal to 50. That's also correct. Okay. So the solution of this system of equations is 10, 50. This means that when x is equal to 10, the expressions 5x and 2x plus 30 both have a value of 50. In other words, y is equal to 50 when x is equal to 10. Okay. Let's learn how to solve a system of equations by graphing. And it says, you can estimate the solution of a system of equation by graphing the equations on the same coordinate plane. So we're going to graph both of the equations, y equals 5x and y is equal to x plus 30, in the same coordinate plane. And it says the order pair for the point of intersection of the graph is the solution of the system. So wherever you see that the two lines intersect, that's where the solution is. Okay, if you see these ones, they intersect in x10. We go right here is 10, right? And right here, which is 50. Oh, I don't know what happened. They went back. Oh, there it is, which is 50. Okay, so in the graph, I'm right here. In the graph shown, the line intersects at only one point. That means that this system of equation has only one solution. Okay, they only intersect one time. So that one time is the solution. Okay, let's do an example to see how can we solve system of equations by graphing. And it says solve the system of equation by graphing and then check your solution. So what we need to do is we need to graph these two right here in this same coordinate plane. Okay, so if you remember, we need to start with the y-intercept. So this graph is going to begin in -2. -3, I mean. -3. This is our y-intercept. That's where my line is going to cross the y-coordinate, the y-axis. And it has a -2 slope. Okay, -2 slope. That means -2 over 1. Since it's negative, it's going down. So it's going to be looking like this. Okay? It's negative. So instead of going up, remember rise over run, instead of going up, it's going to be down because it's negative. So -2, I'm going down 2, and then I'm going to advance 1. Okay, so that's where my point going to be. If you see, it's like really, really short. So we can do it opposite so we can have more points. We can put the 2 positive and the -1, the 1 negative. So this one will go rise, and this one, instead of running this way, it's going to run the opposite way because it's negative. So I'm going up 2, 1, 2, and then I'm going back 1. 1, 2, and then I'm going back 1. 1, 2, I'm going back 1. 1, 2, I'm going back 1. Now we have more points so we can have our graph. I'm going to put the first line right here. Okay, so my graph, it's looking something like this. Okay, the first equation. Now I'm going to graph the second equation. And the second equation has that y-intercept of 5. So that means that I'm going to start in 5. 1, 2, 3, 4, 5, right here. Okay, and it has a positive slope of 2 over 1. Okay, so I'm going up 2 and then advancing 1. But if you see, I don't have any more up here to go up to. So what do I need to do is I need to do it opposite, right? Instead of going up, I'm going down and backwards. So I'm going 2 down, 1, 2, and 1 back. 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 So that way I can draw my second line. Okay, my second line will be something like, I'm going to do it a little bit straight. Something like that. Okay, that's going to be my second line. Now you can easily see where they intersect, right? If you see, they both intersect in this point. So that's going to be my solution for this equation. So it intersects in -2 in x, and in y is 1, -2, 1. That's the solution for this problem. So let's check the order pair. Now we have -2 and 1. So instead of x, we're going to put -2. And instead of y, we're going to put 1. So y, it's 1. Okay? And instead of x, it's -2. So 1, it's equal to -2 times -2, it's 4. Minus 3 is 1. So that's correct, right? So y, instead of y is 1. And instead of x, we have a -2. So 1, it's equal to 2 times -2, it's -4. Plus 5 is 1. So our solution is correct, right? Since both sentences are true, the solution of the system of equations is -2, 1. Okay? Great. Now you pause the video and go ahead and do the check that is on page number 321. Okay, go ahead and do it. Pause the video and then do it in your books. Remember, if you don't have your books, go ahead and do it in your notebooks. Good. So you'll finish your check problem. Okay. Let's continue with example number 2. In example number 2, we're going to continue solving a system of equations with one solution by graphing. And it gives us the equations, okay? The equations that we're going to graph. X equals 3 and y, it's equal to -6. So this is really, really easy. We're going to go to x3, 1, 2, 3. We're going to put a point right there. And then we don't have any y-intercept, so it's not going to intersect y at any point. So that means this graph, it's only a vertical line. Okay, it goes down and it goes that way. And the other one is y equal -6. So we go in the y-axis, -6. 1, 2, 3, 4, 5, 6. Oh, I moved it. So 1, 2, 3, 4, 5, 6. My point is going to be right there. And since I don't have any other point, or I don't have any x, right? That means that I don't have a slope. So it's a horizontal line. You can see when they get together, when they meet, when they intersect, right? Right there. That's our solution. So my solution for this system of equations would be, oh, right here we have it under. It crosses at 3, -6, right? X is 3 and y is -6, where they cross right there. Okay, so we're going to check the order pair. Analyze the equation. X is equal to 3. So instead of 3, instead of x, we're going to put 3. It's equal to 3. And instead of y, it's -6. So -6 is equal to -6. So both are correct. Okay, since x is equal to 3 and y is equal to -6, the solution of the system is 3 and -6. Great. So go ahead and pause this video and do the check problem on page number 322. Good. So you've done the check problem. We're going to continue learning how to write linear equations in a slope-intercept form. So sometimes we're not going to have the linear equations written in the same or the y-intercept form. We have them like scrambled, okay? So if a linear equation is not in a slope-intercept form, you can use the properties of equality to rewrite the equation, okay? What do we need to do? We need to leave y by itself. Remember, our y-intercept form is y is equal to mx plus b. That means that we're going to leave y by itself in one of the sides of the equal sign. So we're going to do this with the following equation. The equation is 4x plus 2y, it's equal to 16. We're going to solve it for y. So what we need to do is we need to subtract the 4x in both sides. Okay? So we're going to leave, this one is eliminated. So 2y, it's equal to 16 minus 4x. Now, we are going to leave the y by itself, so we need to divide by 2. Okay? So these two terms, this one and this one, are going to be affected by the 2. we have to divide both of them by 2. So this 2 is eliminated, so we only have y in this side of the equal sign. So 16 minus 16 divided by 2, it's 8. Minus 4x divided by 2, it's 2x, right? So remember, I usually write it this way, mx plus b. So I'm going to flip this 2, okay? So this one is going to be negative 2x plus 8. Okay, I take the negative with me because this one is negative, so don't forget that one. Okay, so now my equation is written in a slope-intercept form. Good. Let's see example. Let's learn a little bit more about system of equations with no solutions. What that means. Some system of equations have no solutions. If the graph of your lines are parallel, that means that they never intersect, right? Then there is no solution. So right here we have 2 lines. Y is equal to 2x plus 15 and y is equal to 2x. So if we see them, they never intersect. They never meet each other. So in the graph shown, there is no intersection points. So the system has no solution. Okay, so when they never meet, they never cross, that means that they don't have any solution. Okay, how can we know? Sometimes we can know with just seeing them. Okay, right here, they have the same slope. Okay, so that means that they're not going to cross. They're going to be parallel. So example number 3, solve system of equations with no solutions by graphing. Solve the system of equations by graphing. Check the solution. And we have the equations right there. Y is equal to 2/3 x plus 1. And y minus 2/3 x is equal to -3. So the first thing we need to do, we need to have the equations both written in a slope-intercept form. The first one already is, right? Y is equal to mx plus b. If you see, it's already done. It's y by itself in one of the sides. The other one isn't. This one. So we need to put it in a slope-intercept form. So what do? We're going to add 2/3 x to both sides. Oh. Okay. 2/3 x in both sides, right? So this one is eliminated. So y is equal to -3 plus 2/3 x. Then we flip it, right? 2/3 x minus 3. So that's already written in slope form. Now, we're going to graph the equation on the same coordinate plane. Okay, now we have them both written in a slope-intercept form. We're going to graph them. Remember, we start with the y-intercept. The first one, we're going to start in y1, right here. Okay, that's going to be our first point. And it says, remember, 2/3, it means rise over run. So I'm going up 2, 1, 2, and I'm running 3, 1, 2, 3. Okay? If we're going to go to the other side, we put negative on both of them, or we go backwards. Instead of going up, we go down, and instead of advancing, we go back. So we go down 2, 1, 2, and then we go back 3. It's the same thing. Okay. 1, 2, 1, 2, 3. Well, we have 3 points. That's enough. I'm going to draw my graph. So my graph will be something like this. The first one. Now the second one. I'm going to begin. Oh, I moved it. Okay, there it is. I'm going to begin in -3. That's my y-intercept. So I'm going to start in -3 in y. 1, 2, 3. I'm going to start right there. And then I have the same slope, 2/3. So that means that I'm going up 2, 1, 2, and then I'm advancing 3. 1, 2, 3. Okay. if I want to go backwards, instead of going up 2, I'm going go down 2, and then I go back 3. 1, 2, 3. Okay, something like that. I'm going to draw my other line, my second line. Okay. So they will look something like this. So if you see, they never touch, they never intersect themselves. So it means that it has no solution. The question is, do the lines appear to intersect? No, they don't appear to intersect. So the graphs of the lines appear to be parallel lines. Since there is no point that is a solution for both equations, there is no solution for this system of equations. Let's check. Analyze the equations. Rewrite the equation y to third x plus 1. Okay. So we're going to subtract 2x from both sides. So minus, minus 2/3 x minus 2/3 x. Okay, this one's eliminated. So 1, it's equal to y minus 2/3 x. So if you see, the system of equations can be written as follows. Y is equal to negative 2/3 x equals 1. And if we do the other one, we would have y is equal to negative 2/3 x equals to negative 3. Since y minus 2x cannot simultaneously be 1 and negative 3, there is no solution. Okay, it cannot be both. All right, so go ahead and pause this video and do the check problem in page number, let me see where it is. Oh, you don't have a check for this example. So you're free to go to the next example. Let's go to the next example. So let's go and learn how to identify infinitely many solutions, okay? And this one, what we need to do is we need to do pretty much the same thing. The first thing that we need to do is we need to learn that some system of equations have infinitely many solutions. If the graphs of the lines are the same and therefore intersect at every point, then there is an infinite number of solutions. So y is equal to 3x plus 5 is equal to negative 3x plus y equals 5. In the graph shown, the lines intersect at every point. The system of equation has infinite number of solutions, okay? Let's see example number 4. We have y, it's equal to 2x plus 1, and y minus 3 is equal to 2x minus 2. Remember, the first step is we need to put both of the system of equations in y-intercept form. This one already is, but this one isn't. So we're going to write it down, okay? Y minus 3 is equal to 2x minus 2. So we're going to add 3 to both sides. So we end up having y, it's equal to 2x plus 1, okay? If you see, both of them are the same, 2x plus 1. So when we graph them, we're going to graph the 1 first because that's our y-intercept. And we have a 2, so that's 2 over 1, rise over 1. Oh, rise over 1. This one runs over this side. So we go up 2, and then we run 1. We go up 2, and we run 1. So that's where we put our line. Okay, that's where we put our line. So that means that the other graph will also be the same because both of them, oh, I always do the same thing. I move it instead of drawing. So both of the lines are 2x plus 1 of the equations, I mean. So the lines are exactly the same. So when this happens, any ordered pair of the graph of the line will satisfy both equations. So there's an infinite number of solutions for this system of equations. All of the numbers will work right here. Okay, go ahead and pause the video and do the check on page number 326. Okay, to finish the lesson, we're going to do this application. It's on your page number 328. No, 27, I mean. And it says, apply, bake sale. The Spanish Club is having a bake sale. You can buy a bag of trail mix and a loaf of pumpkin bread for $11. Or 3 bags of trail mix and 2 loaves of pumpkin bread for $24. This situation can be represented with the system of equation x plus y is equal to 11 and 3x plus 2y is equal to 24, where x represents the cost of a bag of trail mix and y represents the cost of a loaf of pumpkin bread. How much does each bag of trail mix and each loaf of pumpkin bread cost? So we need to solve this system of equation to find the value of x and the value of y. How are we going to do it? Well, we're going to graph the equations, okay? Since the first equation is x plus y, it's equal to 11. The second equation is 3x first. 3x plus 2y, it's equal to 24. We need to put them in y-intercept form. Okay, we need to leave the y by itself. This one is really easy. We're going to subtract x in both sides. So y, it's equal to negative x plus 11. Okay, now let's do the same thing with this one. We subtract 3x in both sides. So 2y, it's equal to negative 3x plus 24. Now I need to divide by 2. Okay, remember, when we divide by 2 terms, like in this case, both of them are affected. So y, it's equal to negative 3 halves x plus 22 divided by 2, 12. So now we have our systems of equations written in y-intercept form. What we need to do next is that we need to graph them. Okay, we need to graph them. So in this one, we're going to start in positive 11. I'm going to draw a graph right here. Okay, so it's going to be, let's see if I can do it a little bit bigger. 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, I'm sorry about my numbers. It's the best I can read right now. So the first one will be positive 11, my y-intercept, so it will be something like this, positive 11. Okay, and my slope is negative 1. Remember, when we don't have a number with the x, it's a 1. So it's negative 1. That means negative 1 over 1. I go down 1 and I advance 1. I go down 1 and I advance 1. Go down 1 and I advance 1. Okay, these are going to be 1, 2, 3, 4, 5, 1 by 1. Good. So that's our first line. I'm going to draw it. It would be something like this. Okay. Now I'm going to do the second one. The y-intercept is 12. So that's my first point right there in 12. Right there. 12. And then my slope is negative 3 halves. That means that I'm going down 3 and advancing 2. So I go down 3, 2, 3, and advance 2. 1, 2. 1, 2. 1, 2, 3. and advance 2. 1, 2. Okay. So that's where my graph would be. Let's see, I was in 12. So 10, 8, and then 3, 1, 2. So this is 1, 2, 3, 1, 2. Oh, right here. Oh, let me erase this one. Oh, what am I doing? Let me draw the points again. This one's not it. Okay, let me do it again. I think I messed up. And this one. So I'm right here in 12. So if I'm going down, I'm going to go to 9 and then advancing 2. 1, 2. So my first point would be somewhere like this. And I'm going down 3. That's 1, 2, 3, and advancing 2. So it'll be something like that. Then I'm going down 3, 2, 3, and advancing 2. 1, 2. I'm going down 3, 3, and advancing 2. Let me see what's going on here. I know what happened. I did the first one wrong, not the second one. Because of my graph. Let me redo it. Let me do it again. I'm sorry about this. I cannot find my eraser. Oh, it's right here. I'm going to erase every point so I can start again. I'll also erase my graph. There it is. Okay, so here it goes again. I'm sorry. This one would be it. So we'll start in 11. That's our y-intercept in the first one. Okay, the first equation. And -1 is my slope. So -1 and 1. Going down 1, I'm going to 10, and then I'm advancing 1. I'm going down, I'm going to 9 and advancing 1. Down to 8 and advancing 1. Okay, so that's where my mistake was. I was descending 2. So my graph should look something like this. 11. Okay, something like this. Now the second one, ahora sí. It starts in 12, which is right here. And it goes down 3 and advances 2. So it goes down to 10, to 9, and advances 2. 1, 2. Now we can see where it's going to cross, right? It's right there. It's going down 3, so it goes to 8, 6, and advances 2. And then it goes down 3 and advances 2. Okay, so I can draw my second one. My second line will begin right there. And it's going to be something like that. Good. So now we can see where it crosses. Okay, it crosses right there. Let's identify. It's in y9. And x is 2. Okay, this is 2. So that means if we go back to our problem, x represents the cost of a bag of trail mix. So the bag of trail mix costs $2. And y represents the cost of a loaf of pumpkin bread. The loaf of bread cost $9. I'm sorry about all that. I hope that you got it. Very good. Go ahead and do the check problem. on page number 328. All right. This is the end of the lesson. Tomorrow you'll be working on the practice. So good luck. Have a great, great day.